My name's Brian Wardle, and it's myself and Mike who teach physics at QA. So thank you very much for coming along this evening and participating. So how we plan to run it this evening is I'm going to talk a bit about the course. We've got a 20-minute session, so I'm going to talk the course for about 10 minutes, and then Mike's going to field any questions you've got. So if, while I'm just talking away, if you want to ask a question, if you just put it into the chat, then Mike will either answer it there and then, or he'll come back to it at the end of my spiel bit. So don't think I'm ignoring you if you type a question in, but Mike will come back to that in due time. All right, so first of all, why physics? Why would you even consider doing physics? Because people recognize physics as being quite a difficult option. So it is a demanding A level, but the reasons why you should consider doing it is that it is demanding, and consequently universities, employees recognize it as a demanding course. So they know someone who come through from a physics course has got high levels of academic ability, but they know full well that physics does develop certain qualities in a student. You've got to develop thinking skills, you've got to develop rational thinking, the ability to use reasoning work, logic work, problem solving skills. You develop team building skills as we go through doing practical work, and some homework is set in groups, so you have to work together. Small number of homework is done in groups, so you have to work together collaboratively. And often a lot of our students will set up little groups on WhatsApp or whatever, and they'll help each other through the homeworks. So physics it's a well-recognized academic course, so it holds you in good stead for any future development. What else have I put? I've just got some notes I jotted down here because my mind goes blank as soon as I'm putting the camera in front of myself. So I've got fundamentally it's in many ways it's the most basic fundamental of the three sciences. It's physics which underpins your chemistry and underpins in some ways your biology. Your main two physics theories today, your general, your relativity and your quantum theory. Basically, the quantum theory helps to explain chemistry. Quantum theory tells us how the atoms interact with each other. And there's also now quantum theories going into biology. So, higher level biology, they start talking about quantum biology courses at university. Physics is just natural curiosity. If you want to understand, if you've ever sat there at some stage in life thinking, looking at the stars at night or something, it's the science which will probably answer the big questions about the universe. Why are we here? What is time? Does time only move forward? Again, what is time? It's one of the things I was always asked myself, what is time? And did my degree course, and I still didn't know what time was fully. Had a better understanding, but I still didn't know what time was. So yeah, physics it's one which will answer those naturally big questions, which as a human race we've asked ourselves through the eons. Okay, so I think that covers those ones there. I'll fling that one to one side. It's an excellent course. It covers many things. If you're interested in these big questions, you'll enjoy doing physics. You will enjoy doing physics. The course we choose to do at QE is, I'll just grab a textbook, is this one. We do physics OCR, Oxford, Cambridge. Again, very traditional board, but it's they run two options. And we choose to do option A. And that's, can you judge a course by the thickness of a textbook? There's loads of stuff in there, but more importantly, as I said, it's the thinking skills you develop as a consequence of doing a course. Key principles like your conservation laws, conservation of energy, conservation of charges, key conservation laws. And so the idea is in some ways a little bit cyclic and repetitive, but you eventually hopefully get to underpin the main themes in the course. How's it taught? Well, basically there are two major modules for each year. In the first year, there's two major modules, and the second year, there's two major modules, and it's practical work interwoven on top. Most of the time, we look to split the classes between myself and Mike. I say most of the time because this year, the way timetable worked out, we couldn't actually do that this year for all our groups. But in general, we look to split each class. So I teach one module and Mike will teach one module each year. Okay. How much practical work? We look to try to do as much practical work as we can fit in there. There is some kind of assessed practical work called PAGs, but regardless of those, we look to try to use practical work to either introduce topics or to consolidate topics, or just in general to try and pique interest in the subject as we go through. So yeah, we like to do lots of practical work when we can. The other thing I noted down here is other resources that we like to use to try and support your learning. We've got, every student gets a copy of a textbook to help them through a 2-year course. We use an online resource called Caboodle. We use Isaac Physics, and we use lots of online resources where we can to try and help students through. And we make easy access to resources via Google Classroom and Google Sites to help you find these resources, hopefully conveniently and quickly. I'm just looking down at time to see where I'm going. Last thing I wanted to say, and then I'll hand it over to Mike, is entrance requirements. Entrance requirements, basically, if you're doing individual sciences, we're looking at a 6 in the physics or above. And also, if you're doing dual water, it'd be 2 6s. But we're also interested in your maths side of things as well. Now, previously, we used to ask for people to do maths A level, but for the last couple of years, 3 years, since the requirements nationally have gone down to just following 3 subjects at A level, we've dropped that specific requirement. Okay, so you don't have to actually do maths A level to do the physics course. So those of you more on, say, the medicine side of things, obviously definitely want to be doing your biology, chemistry, it would make sense to us to consider doing physics as well. But of course, there's your 3 subjects, no room for maths. So yes, you can do physics A level and not do maths A level. We would err on the side of caution and say that would probably hinder your chances of taking physics any further, because if you're down the medicine side of things, you're not going to be taking physics any further. So maths is incredibly useful to us. Maths is incredibly useful to us in physics, but you don't have to be doing the A level. We will make sure we teach you the math skills you need as a consequence of following the course. Right, okay. I'm sorry, that was very brief, very quick, but I've been told it's only meant to be a 20-minute session this evening. So I've tried to consolidate it down, but maybe they've gone through things too quickly. That's good, because it leaves it for Mike to pick up the pieces. So Mike, did we get any questions coming in? I haven't got a clue.
We got a few coming in. One of them you answered just as a natural kind of response to going through your spiel anyway. We've had a couple of general ones. Someone's asked if you can only do 4 A levels, or so if you can only do 3 A levels, or if you can do 4. And generally we would recommend for the majority of students, 3 A levels would be a full course of study. Generally, if people are doing 4 A levels, it tends to be with maths and further maths as 2, and then 2 subjects alongside. And a lot of physics students pick that option to do those. But in the majority of cases, it would be 3 A levels. We've got a question that I think we've probably answered actually from an anonymous attendee who has asked, would you recommend A level physics if they were going to go into medicine? And so I think Brian's already kind of said, like, obviously you can. The obvious A levels that you should do if you want to do medicine would be chemistry and biology, but then doing physics alongside works really well and supports those 2 A levels. And we've had a few students who've gone on to do medicine after having done physics A level. Another anonymous attendee, or one who's asked a lot of questions, has asked us about what courses could they take at university if they do physics as an A level. And there are some courses where they would require you to have physics A level. So physics would require physics A level generally. But then also a lot of engineering courses would look for physics A level as well. It's then also, there are some courses that look for 2 sciences, or certainly doing 2 sciences doesn't narrow down your options when it comes to university courses. So there's a lot of options there. And we do cover medical physics as part of the second year of the course. So
Mike, is my textbook upside down there?
No, that's the right way around for me.
It's the right way around. Okay, because it's upside down on my camera view here.
Yeah.
So someone's asked about the different modules. So do you want to talk?
Yeah, so Hannah's asked about the modules.
I'll let you talk through it because it's upside down to me.
Okay. So we in the first year we cover forces of motion, which you might be able to see the textbook up on the screen now. And that's we start off with literally speed is distance over time, and then we move on through looking at forces, and then some materials work, and we look at energy, and we move on to Newton's laws of motion at the end of the course. And then the side of the course that I teach at the moment in the first year is pretty much split 50-50 between electricity and waves. And so we start off with electricity work and how we can use electricity as up to sensors. And then we move on to looking at how waves work, and we look at water waves and electromagnetic waves, and then a little bit of quantum mechanics at the end of the first year, where we start thinking about particles as, we start thinking of light as particles, not just as waves. And then the second year kind of follows on. So for one half of the course, we look at thermal physics and gases, and then we go through circular motion and oscillating movements like pendulums and masses on springs, and then into all the exciting, cool space work. So I've just looked at satellites today with my classes. And then in the other half of the course, we do some more electricity work. So we have capacitors, and we go through particle physics, and then into radiation and nuclear physics and medical imaging. So you can see it's quite a wide-ranging course.
Yeah, okay, if I just cut in there for a second.
Yeah, go on.
Sorry, Mike, I just stopped doing full spiel there. Just basic, one thing I did have in my notes, but I didn't say is one of the reasons why we picked the OCR A option when we rejigged course, when the course rejigged around a few years ago, is because this course has, as you can see here, a big chunk of what we feel from our reading open evenings in the past, students are interested in. Students are interested in the astrophysics and cosmology side of things. So we've got 2 big chunks of that on this course. Also, every year you get students talking about quarks, and some even come up to me talk about squawks these days, and all these new fandangled things I read about from the wonderful internet. So this course has got a huge amount of cosmology aspects to it, but it's also got a big chunk of particle physics, where you get your quarks, your muons, hadrons, leptons, all these sort of things, antimatter stuff. Been a lot of radioactivity, a lot of nuclear physics stuff going on. And again, for those interested more in medical physics, it's a big chunk of medical physics for people to get their teeth stuck into, literally. Sorry, Mike, I just had to put that bit in.
That's okay. I've been answering a couple of text questions as well while you've done that. So we've had somebody's asked about engineering, and obviously physics is one of the major A levels there, but then maths alongside that. And depending on which type of courses you're going for, you might want to look at chemistry, and you might want to think about further maths as well for engineering, but it would depend on precisely what university courses you would be looking at. Got a question about veterinary science. I'd imagine similar to medicine. I don't think it would hurt having the physics course. I don't think any veterinary colleges would look for it specifically, but I don't think it wouldn't hinder your chances of getting in.
I mean, at the end of the day, physics allows us to understand how your X-rays and gamma rays interact with matter, and ultimately the medics. How are you going to do your big chunk of medicine these days is in medical physics departments. You're using physics as both a diagnostic technique as well as a technique for actually trying to treat people. So to have a base ground understanding in your physics, to me, would be incredibly useful to anybody considering a medicine discipline, whether veterinary or straight medicine. There are some countries in this world who still, for their medical courses, will still insist on students studying physics before they can get onto their medical physics courses. I don't know why. To me, it's a shame that they don't ask for that, because, you know, one of the big things we talk on our course is a PET scan. Hopefully, you may or may not have heard of a PET scan, but PET stands for positron emission tomography. You know, if you go for a PET scan, they will induce something called a positron. They'll create a positron inside of your body. Now, a positron, believe it or not, is an antimatter particle. It will induce antimatter inside your body, which will annihilate with a matter particle in your body, which will produce some gamma ray photons to come flying out your body. You know, it's all physics, all quality physics. Sorry, Mike, back to you.
That's okay. So we've got a question here about the fact that not all students have had equal quality online learning, and would we take that into consideration when teaching or recapping subjects? So I think we kind of do that anyway, because we have such a range of students, and some, you know, we might have some students who've got a 6-6 in double science, or what you might call triple science, but it's where you're doing 2 GCSEs worth of science. And then we might have other students who've got a grade 9 in the separate physics. So we already kind of go back over a lot of the content, and part of our first year is recapping some of the end of the GCSE course as well. So I think we always have very different entry levels from different students from different schools anyway.
Yeah, I mean, ultimately, success in physics it's really determined mainly by by you as a student. It's really determined by how much effort you put in. We can teach the theory, we can show you resources, but it's down to the tenacity of a student and how much they get stuck into the course, which is by far the biggest factor of your success at A level. So if you haven't had the greatest experience, I wouldn't worry about that. If you're prepared to work hard, you're prepared to use the resources we point you towards, if you're prepared to come back and ask Mike and myself extra questions, if you've got that level, as I said, I use the word again, tenacity, you know, you're in good stead for being successful at A-level physics.
Yeah, we've got a question here that I have no idea about at all, Brian. You might know. Neve wants to know if she would need maths A-level for seismology or volcanology.
Look, maths is everywhere, to be honest. Yeah. Isn't it? Maths is everywhere. It's not going to do you any harm, but I wouldn't know specific. I don't know what the courses ask for around the country. But one thing I do know is that we have excellent careers advisors at our college, and you know, I would always point any student to go and talk to them, because their job, it's unlike in a school scenario when often your careers advisor is a teacher who's been given a sideline in doing careers. We have people which are purely there to do careers advice. That's their whole job. So they keep on top of all the ins and outs of what courses are asking for, and they give excellent advice to our students.
Okay, I'm just sending one last text reply. I think we've run out of questions there. We've answered 21 questions altogether.
Excellent. And we've done it within 20 minutes. Look, it's smack on 20 past 5. So I'm pleased with that. Okay, so if we don't have any other students, and all I can say is thank you very much for coming along this evening. I hope that's a bit of food for thought, but as I said, that's very brief. If at any stage over the next few months you want any more information about the course or anything springs to mind, just make sure you email, keep an eye on the college website. You can look, maybe find some answers on there, but if you want to be directly about physics, just email the inquiries at QE and they'll pass the emails on to myself and Mike, and we'll endeavour our best to get back to you to answer the questions best we can.